Hey guys, welcome back to Algebra 2. Today we're going to be talking about a new chapter, Chapter 5. Chapter 5 is about radicals, rational exponents, and then also nth roots. So what is an nth root? Well, right here we have the definition. By the way, we're on page 218 in your workbook. We have the definition that an nth root of a number c is x such that x raised to the nth power equals c. So let's take an equation that we can agree on. Let's say that 3 squared equals 9. So if I wanted to take the nth root of a number, what this is saying is that the nth root, so like the square root of 9 equals 3. So the nth root. So let's take a higher power. Let's say 2 to the third power I know to be 8. So the nth root, in this case, the n would be 3. So the cubed root of 2 would be, the cubed root of 8 would be 2. So when we're talking about nth roots, what that's talking about is taking different types of roots. You guys are used to taking square roots, so the square root of 9 feels pretty familiar to you. Well, there are also cubed roots, there's fourth roots, fifth roots, and any root I want to, I can just change by changing that number there. So let's talk about some notation. If I have, let's say x equals the nth root of c. The n, that number up there, is called the index. So for this one right here, the cubed root of 8, the index would be a 3. For the square root of 9, there's no number written outside, but when there's no number written outside, we understand that that index would be a 2. So the index is the little number on the outside of the radical. If not written, we assume that it's 2. And maybe a better word than assume would be to understand that it's 2. The c on the inside, we call that part the radicand. And that's whatever you're taking the root of. And then whatever that equals is the x. So you have your power chart that you filled out a little bit before. All right, and here's how I can use my power chart. Let's say I wanted to find the fourth root of, actually, no, not the fourth root. Let's do the seventh root of 128. So to use my power chart, I would go to the seventh powers, the seventh root, find 128. And the seventh root of 128 is 2. And it's 2 because 2 raised to the seventh power is 128. In other words, 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 times 2 times 2 is 128. So this chapter we will be finding all kinds of roots in lots and lots of different ways. So one option for finding a root is to use your power chart. Power chart's really handy. You can use it quickly. You don't have to grab a calculator. Another way to find roots is to use a calculator. So here's Desmos. You're used to seeing the Desmos graphing calculator, and you can find roots here. You'll just need to go into the functions menu under miscellaneous and click the root that has the n on there, and then type in whatever root. So if I wanted to find the seventh root of 128, I'll find it right there. I do need you to note, though, whatever root this is going to give you, it's only going to give you the positive root. Sometimes you'll need positive roots and negative roots, but we'll talk about that in just a minute. Let's see. Any other ways that you can find roots? Not for right now. Okay, so next, let's look at example 1, where we have to find all real nth roots. So I need to find all real fourth roots of 81. So what I can do to find this is I can set up an equation. Fourth roots, which means I'm going to need to take the fourth root, right? So x to the fourth, so I can set up an equation, x to the fourth equals 81. Okay, so if I want to solve this equation, I'll need to undo what's happening here. X is being raised to the fourth power. So to undo that, I'll need to take the fourth root of x to the fourth, and I'll also need to take the fourth root of 81. Well, the fourth root of x to the fourth is just x, and the fourth root of 81, I can grab my power chart. Fourth root of 81 is 3, and I can get 3. Now remember, it does say find all real roots. So when I have the equation x to the fourth equals 81, what I'm asking is what number times itself 4 times will give me 81. Well, we just said 3 times 3 times 3 times 3. All that equals 81. But if I make all these 3's negative, I also get 81 because negative times a negative is a positive. Another negative times another negative is a positive, and then a positive times a positive is positive, so positive 81. So really, if I'm taking a root here of the fourth root, I need a plus or minus 3. So right now, all of my real nth roots are positive 3 and negative 3. Now, in case you're wondering, here's a note. Recall that fourth degree equations from chapter 3 have 4 solutions. Notice I've only found 3. I've found the real ones, and that's all I'm asked to find right now. So this method will give you real roots. If you want to find the imaginary, you're going to have to set it equal to 0, factor, and solve. But this chapter, we are only focusing on the real roots. So I only need positive 3 and negative 3 here. So we can isolate it and take the root. Here's another example. If I want to find the real cube roots of 64, I could set up the equation x cubed equals 64. Take the cubed root of both sides. The cubed root of 64, let me grab my power chart. 64, the cubed root of 64 is 4. So x would be 4. And so just a reminder, I'm looking for what number times itself 3 times is going to be 64. Well, we solved it and got 4, but do I need a plus or minus here? Will negative 4 multiplied by itself 3 times equal positive 64? Negative 4 times negative 4 is positive 4, and then a positive times a negative is negative 64. So negative 4 times negative 4 times negative 4 does not give me 4. So a real cube root only has 1 real root. So here's what you need to remember. If you are taking an even root, what you'll need to do is write a plus or minus. Because even roots have 2 real roots, odd roots have 1 real root. So you need a plus or minus. Numbers with even index have 2 real roots. Numbers with odd index have 1 real root. So you'll need the plus or minus for the even index and just the whatever number you get for the odd. All right, the next thing we need to talk about is how to interpret a fraction exponent. When I say fraction exponent, I mean something like 5 raised to the 2/3. Because now we're going to have exponents that are fractions. Okay, well, here's an interpretation from the textbook. In general, if the nth root of c is a real number, such that the nth root of c equals c to the 1 over n. So let me clarify this a little bit. This c is raised to the first power. So the index ends up being the denominator, and the exponent ends up being the root. So this 5 to 2/3 means the same thing as the cubed root of 5 squared. Cubed root of 5 squared. Now I can square 5 first and take the cubed root, or I can also take the cubed root of 5 and then square it. The order of whatever you're doing does not matter. You'll still get the same number because it's like multiplication here one way or undoing multiplication. So the order doesn't matter. It's just that one method may be more convenient for the other. So sometimes it might be easier for you to square something and then take the cubed root. Other times you might see that squaring something makes the number too large and then taking the root makes it hard to do. But that's what a fractional exponent means. Now, it is important to recognize the multiple representations of the same value, so you can use the most efficient method for a given situation. So that will make it easier on yourself if you are familiar with the multiple representations. So in example 2, you have to explain what each fractional exponent means and then evaluate. So 25 to the 1/2. Now, what helps me remember this is a picture. So I'm going to draw a picture of a tree. There's the bark, there's the leaves, and then underground, we have, the tree has roots. Now, I'm not an art major, remember, I was a math major, but these are roots. Where do roots grow? Under the ground. On a fraction, what's that? A root. The root is under, on the denominator. So the roots are on the bottom, and then the exponent or the power is at the top. So 25 to the 1/2 is the same thing as the square root of 25 to the first power. Now, remember we said if you're taking a square root, that's the same as just taking the square root and you don't have to write the 2. And then also anything to the first power is understood to be that. So the square root of 25 is 5. Now, I am taking an even root. However, I'm not solving an equation and it doesn't ask me for all of them. So I don't need the plus or minus. This is referred to as the principal root. The principal root is only the positive root. When do you need both? When do you need the plus or the minus? You need the plus or the minus if you're in a situation where you have to solve an equation. So solving an equation, I would need a plus or a minus. If I just were to ask you, well, what's the square root of 81? Then I want you to tell me that it's just 9. If I have the equation x squared equals 81, then I want you to tell me that x equals plus or minus 9 because you're giving me the possibilities for x. But if you just have the square root and you're not solving an equation, you just tell me that it is 9. All right, example B, 32 to the 2/5. Okay, so this is the same as the 5th root of 32 squared. Now here's an example of it might be easier to do it one way versus the other. So I'll do it both ways, and then we can evaluate which way was easier. So the 5th root of 32 squared, or do I want to take the 5th root of 32 and then square that result? Which one's going to be easier for me to do? Let's try it the first way first. So first I need to square 32. So 32 squared is 1024. And then I'll pull up my power chart. The 5th root of 1024 is 4. Or you could go to Desmos and type in the 5th root of 124. Now, let's see what happens if I do it the other way. What is the 5th root of 32? So I go to my power chart. The 5th root of 32 is 2. And then 2 squared is 4. So 2 squared is 4. So both methods will give me 4 as my answer. It's just that one method might deal with smaller numbers, and it might be more efficient for you to work with the smaller numbers. So squaring 2 versus the 5th root of 1024. And you just need to be fluent with whichever method is going to be most convenient at the time you need it to be. All right, now, many expressions with integer roots can be evaluated using mental math, or like using your power chart and then a little bit of mental math as well. However, sometimes the root's not an integer And it could be efficient to use the power function of a calculator to compute those rational roots. So let's see what happens with the numbers in example 3. So what's the value of each expression? For part A, I have negative 16 to the 3/4. Notice that negative is on the outside of the parentheses. So I'm going to evaluate it, negative, and then I'll have parentheses here, deal with what's going on. The 4th root of 16 cubed. Or I can make it negative 4th root of 16 and then cube that. Whichever one's going to be easier. In this case for me, I don't want to cube 16. I'm going to try to find the 4th root of 16 and then cube it. So I'm going to choose the second option. So let's evaluate here. The 4th root of 16, if I grab my power chart once again, 16 is right here. The 4th root of 16, I'm on the 4th power, so the 4th root of 16 is 2. So 2 to the 3rd. And remember, we follow order of operations, so that says that I need to do the exponents. So 2 cubed is 8, so this is equal to negative 8. So that one I did not need a calculator for. And then also notice the directions say to round to the nearest hundredth, which means for this problem, decimals are okay. Sometimes they'll tell you to use radical notation, and that means decimals are not okay. But since it says nearest hundredth, decimals are okay. Oh, decimal right here. Okay. The 5th root of 3.5 to the 4th. 3.5 is not on my power chart, so I am going to grab Desmos. Now, if you get tired of clicking here and going to functions and miscellaneous, the other option you have is to go to the Desmos website. Instead of clicking graphing calculator, go to math tools and click the scientific calculator. Then that option is right there for you. So I want to do the 5th root of 3.5 to the 4th power, 2.724, and I'm going to round to the nearest hundredth, which is 2 decimals. So 2.72. All right, then I'll evaluate all of these and see what happens. So 32 to the 3/5, that would be the 5th root. I'm working on this one right now. 32 raised to the 3rd power. Let's see, I feel like we did this one because the 5th root of 32 is 8, and then 8 cubed. No, not the 5th root of 32. The 5th root of 32 is 2, and 2 cubed is 8. So this is the same as 2 cubed, which is 8. Perfect. All right, 27 to the negative 2/3. Reminder from Algebra 1, whenever you have something to a negative exponent, negative exponents mean division. So this is the same as 1 over 27 to the positive 2/3. So that's the same as 1 over the cubed root of 27 squared. Now I know what the cubed root of 27 is, so I'm going to take the cubed root of 27 first, and then I'm going to square that result. So 1 over the cubed root of 27 is 3, and 3 squared is 9, so this is equal to 1/9. And then 50 to the 3/4. Since I am allowed to use my calculator, I will if I need to. That means it's the 4th root of 50 cubed. So let me grab my Desmos calculator. The 4th root of 50 cubed. 18.80. Approximately. All right, let's talk about simplifying nth roots. So we're going to use the property of radicals. This again is review from Algebra 1. There's a property of radicals that says if I have the square root of a number times something else, I can split that up into individual radicals. And then I can put them back together. I can do that as long as this index is the same. So as long as, let's say these were both fourth roots, I can have them separate and put them back together, or I can keep them one and separate them into two fourth roots. As long as the indices are the same, then you can break apart or put back together as you need. So we're going to take that here. We're going to simplify the expression, the cubed root of negative 8, a cubed, b to the ninth. So I'm going to split that up. The cubed root of negative 8 times the cubed root of a to the third times the cubed root of b to the ninth. Okay, the cubed root of negative 8, well, what number times itself 3 times is 8? Well, that's 2, but I need negative 8, so we'll have negative 2. Whenever you are trying to take a root of a variable, the cubed root of a cubed is asking, means, what number or what thing times itself 3 times is going to be a cubed? Well, a times a times a. So this is equal to a. The shortcut for that, so that I don't have to think about that the long way every time, is to divide. If you divide this number by that, we get a to the first power. So then I can also apply that here. The cubed root of b to the ninth is the same as b to the 9 over 3, which is b cubed. So my answer is negative 2a b cubed. On part B, I have the fourth root of 256, x to the 12th, y to the 24th. So again, I'm going to split that up into the fourth root of 256, the fourth root of x to the 12th, and the fourth root of y to the 24th. All right, well, the fourth root of 256 is 4. I need multiplication symbols here. The fourth root of x to the 12th is the same as x to the 12 over 4. And the fourth root of y to the 24th is the same as y to the 24 over 4. So if I do that division, 4x to the third, y 24 over 4 is y to the 6th. Now, we do have to worry a little bit about being specific whenever we're taking even roots, because remember, we're only dealing in the real numbers right now, so we have to be very careful that our answers are only going to give us something. We do have to be careful when we're taking even roots, because remember, we are working with only the real numbers, so I have to make sure that my answer is only going to give me something that is going to be real. So whenever you take an even root, you have to make sure that everything that's underneath or whatever you get is going to be positive. Well, 4 is always positive, no matter what 4 is. Y to the 6th is always going to be positive, because anything to an even power is positive. If y were positive, positive to the 6th power is positive. If y was negative, a negative to the 6th power is positive. Where we have to be concerned is right here at x cubed, because if x was a positive number, that number cubed is positive. But if x was a negative number, that would be a negative number. So to fix that, we're going to put absolute value bars around the thing that could be negative. So whenever you're taking an even root, the answer must be positive. Because if you take the even root of a negative number, you'll get an imaginary number. So that's how we keep our answers positive. So here's how you can tell what needs absolute value bars and what does not need absolute value bars. So in general, if you take an even root, and the variable has an odd exponent, you need absolute value bars. So here I was taking an even root. I ended up with an odd variable exponent, so that part needed absolute value bars. So let me show you another one where that happens. Let's say I was going to take the square root of 16 x to the 10th. I would get 4. Oh, wait, I forgot to divide it up. Sorry, skipping ahead. That's the same as the square root of 16 times the square root of x to the 10th. The square root of 16 is 4. The square root of x to the 10th is x to the 10 over 2, which is 5. So 4 over x to the 5th. So I took an even root, and I got something that had a variable with an odd exponent, so I need absolute value bars around the x to the 5. So here's my answers for those two problems. You're not always going to need absolute value bars. If the problem says assume all variables are positive, you don't need to worry about absolute value bars. I'm going to abbreviate value val bars. So if it's telling you, well, in this problem, all the variables are positive anyway, and when you take a root, you're just going to get a positive answer, then you would not need absolute value bars. So look for, whenever you're doing your assignment, look for this phrase, assume all assume all variables are positive. If you see this, that's an indication to you that your answer does not need absolute value bars. If you don't, you'll need them in there. All right, then we're going to use nth roots to solve equations. All right, so here's what you're going to need to do. The first thing before you do this, what's over here, you need to isolate the variable. So get that variable all by itself first, and then you can use the power property where you raise it to the 1 over whatever the exponent is, or you can take that root. And I'll show you what both methods look like. So first of all, I've got 5x to the 3rd equals 320. To isolate the variable, divide both sides by 5. We get x cubed equals 64. So there's two ways I could do this. First way is to take the cubed root of both sides. So the cubed root of x cubed would be x. The cubed root of 64 is 4. So there's one way. The other way that I could do this is I could say, okay, well, here's my problem, x cubed equals 64. I can raise both sides to the 1 over whatever the exponent is. And that'll give me the same answer because you would multiply exponents here. 3 times 1/3 is 1. And 64 to the 1/3 is also 4. So both ways will get you the correct answer. One way may be more convenient than the other way. Sometimes you have to do the fraction method. Some ways you can only do the radical method. It kind of depends on the problem and the scenario that you give. So here's another one. 2p to the 4th equals 162. Again, divide both sides by the 2. You've got p to the 4th equals, I don't know, what's 162 divided by 2? 81. So let's try that other method where I raise both sides to the 1/4 power, because that's going to come into play next unit or next section. P to the 4 times 1/4 is 1, so this is P. And 81 to the 1/4 is 3. And this is the same as taking a root, so I need a plus or minus because I am solving an equation. And then finally, we have a word problem. One cube has an edge length 3 centimeters shorter than the edge length of a second cube. So let me draw some shapes here. All right, one cube has an edge length 3 centimeters shorter than the edge length of the second cube. So I will say X is going to be edge length of second cube. So I'll label this X, and since it's a cube, all sides have the same length. And if the other one is 3 centimeters shorter, we'll call it X minus 3, X minus 3, X minus 3. The volume of the smaller cube is 200 cubic centimeters. What is the volume of the larger cube? So pretty much I need to figure out what X is, because I know that the volume of a cube, say volume larger, the volume of a cube is equal to the side length times itself 3 times, or the side length cubed. So I'm going to take what I have with a smaller cube, find X, and then find out the other sides. So the volume of the smaller cube is 200. Each side is X minus 3 cubed. So I've got to solve this equation. Well, something is being cubed, so to uncube it, I'll take the cube root of both sides. Cubed root, cubed root. Looks like I can round on this one, so I'm going to find the cubed root of 200. It's about 5.848. So then if I want to solve for X, I'll add 3 to both sides. So it looks like X is approximately 8.848. So if I want to find the volume of this cube, V sub L means volume of the larger cube, I'll take 8.848. I will cube it. And you get about 692.684. Yeah, 684 cubic centimeters.